Dear students, let us continue our learning on the course Automata Theory and Computability. We are in the fourth session of the module 4. In the first three sessions, we learned the decidable languages, and then next we learned the architecture of the Turing machine. Then next we have seen some of the examples of the Turing machine. Then let us continue our learning on the design of the Turing machine. Herein, we are going to consider the first example which will be normally asked in the examinations. Myself, Dr. Suresha D. from the Department of Computer Science and Engineering of Canara Engineering College, Bantwal, Mangaluru. The question is, we have to design a Turing machine that accepts 0 power n and the 1 power n, wherein n greater than or equal to 1. That is, the minimum value for n will be equal to 1. Fine. So, whenever any question has been asked, we have to look at the constraints over there. So, there is a variation over there. N greater than or equal to 0 will be one more variation, for which I will continue at the end of this session. I will explain how to handle the scenario when the question is n greater than or equal to 0. So, now in this case, the n value is greater than or equal to 1. So, while for designing the Turing machine for this one, so now you have to take an example first. So, consider an example with some 3 zeros and the 3 ones over here for this example. So, 3 zeros and the 3 ones I have taken for the example. For designing the Turing machine, so how we will normally do is, so whenever we see any symbol, we replace that symbol with some other symbol as if we have seen that symbol. So we will mark it. Fine. So in this case, so for the 0, I will replace with the x. First 0, whenever I will get, I will replace with the x. Then I will go in search of the matching 1 for it, because for 0 power n, 1 power n means for every 0, I should have the 1. Once I see my first 0, I will replace with x. The next zeros, I will retain them as it is. I will go in search of the 1. Once I get my 1, again I will replace the 1 with y, and I will go back till I get the next 0. Next 0 will be next to this x. So means I will keep on going back till I get the x. Once I get my x, again I will reset back and I will replace this 0 with the x. Again I will go front, the second one I will replace with the y. Again I will come back, then the next 0 I will replace with the x. Again I will go front and I will replace 1 with the y. Then again I will come back and I found that there are no more zeros are there. Then directly on my start state I will get my y. So I will keep on processing these y's. At the end I should get the blank. In place of blank, if I get one more 1, means it is imbalanced. It is supposed to be rejected. It is supposed to be rejected. I should get the blank. Once I get the blank, then the meaning that it is a balanced one. That is a 0 power n. For every 0 there is a 1. So or else one more option is, if have a 0, then the matching 1 is not there. Again it is an imbalanced one. So in these two circumstances, we are going to announce the error message, or else we will give the acceptance message. Now let us learn how this can be, how we can able to design the Turing machine for this one. Fine. So first, let me take the same example again. So 3 zeros I will take up and the 3 ones. And all the moments I will write it on the left side. So I will start from the start state. My start state, let me take it as Q0. So Q0, the first possibility is a 0. So once I have Q0 on 0, so I will start from here, Q0 on 0. So now I saw my first 0 over there. So this 0 I will replace with x, and I will change the state to Q1, and I will have the right moment over there. Because for the Turing machine, as I told earlier, there are two moments are allowable. One will be the right moment, other is the left moment over there. This moment I am going to write it over here. So what the change in the state? Q0 to Q1 I am changing. 0 I am replacing with x, and I am making the right moment over there. So 0 replaced with x and I am making the right moment. Now what is the left out string for us? 0, 0, 1, 1, 1. So now what I have? Q1 on 0 I have. Q1 on 0 I have. So now for the Q1 on 0, so now I saw first 0. That's why I changed the state to Q1. So I am there in Q1 means what? I have seen the 0. I am in I am looking at the I am in Q1 means I have seen the input 0 over there. Now I am in a search of 1 for that corresponding 0 which I saw earlier. Means whatever the rest of the zeros are there, I won't do anything. I will just keep on moving right side till I get the 1. So Q1 as it is, 0 as it is, and I will have the right moment. That is x 0 Q1 0 1 1 1. The next case again Q1 on 0. What to do? Repeat the same operation. X as it is, 0 as it is, 0 as it is, Q1 on next is 1 1 1. So now what I have? Q1 on 1. So now this is an 1 which corresponds to the first 0. Which corresponds to the first 0. So now Q1 on 1. Q1 on 1. So now as I told earlier, so 1 I will replace with the y. 1 I replace with the y. So now what I need? I need to go back till I get my left 0. What is next to the left 0? I have the x. So till I have the x, I need to go back. Go back means which direction? I need to move left. For going back, I will use a different state. Let the state be Q2. Let the state be Q2, Q2, Y and the left moment I have. So now after this one what happens? X as it is. So now I have the left moment. So 0, Q2 will come here. 0, 1 as replaced with the Y and the 2 ones are left out. So now what I have? Q2 on 0. Q2 on 0. So till I get my x, I need to come back. Q2 on 0, I need to come back. So how to come back? Q2 as it is, 0 as it is, and I need to have the left moment over there. That is x, Q2, 0, 0, y, 1, 1. Again Q2 on 0, repeat the same step. That is what happens now. X, Q2. So this is a Q2, X, 0, 0, Y, 1, 1. Now I have Q2 on X. Means I have reached the left hand. Now I reached the left hand. I need to reset back to set 0 to X. Which state it will set 0 to x? That is a state Q0. That is a Q2 on x. I need to reset back to Q2 on x. I need to reset back to Q0 x as it is. On which side have the 0? Right side. So the moment will be the right side again. So now what happens here? This will be x. Q2 is replaced with Q0. Left out is 0, 0, y, 1, 1. Again Q0 on 0. This is a step. What is Q0 on 0? 0 is replaced with x. 0 is replaced with x. Change the state to Q1. Q1 on next is 0, y, 1, 1. Again Q1 on 0 defined already. What to do? You have to retain 0 as it is and I need to make the right moment. How it will be? X, 0, Q1, Y, 1, 1. Now I got Q1 on Y. So I need to search for 1. If I get the Y, I need to just move front. That is a Q1 on y, which is not defined already, that we are defining. Q1 on y, Q1 as it is, Q1 as it is, Y as it is, and I need to have the right moment over there. That is X, that will be X, 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 0, Y, Q1, 1, 1. Again, Q1 on 1. So now this Q1 I need to replace with Y. So now what will I get? This 1 I need to replace with the Y. So I will get it as a X, X, 0. So on replacing with Y, I need to make the left moment. Left moment means I will come over here. That is a Q2, Y. This is my first Y, this one. Then the second one is replaced with the Y and the 1. So again, Q2 on Y. Q2 on Y is not defined. So we have to define it again. So Q2 on Y, I need to go back. How to go back? Q2 as it is, Y as it is, and I need to make the left movement over there. So now what happens? X, X, Q2, 0, Y, Y, and the 1. Again, Q2 on 0 is defined already. What is that one? We need to make the left movement. So if we make the left movement, what it will be? X, Q2, X, 0, Y, Y, and the 1. Again, Q2 on X. What to do? We have to reset to Q0 again. So that is X, X, Q0, 0, Y, Y, and the 1. Again, Q0 on 0. So what to do for Q0 on 0? This one. What to do for this one? I need to change the state to Q1. I need to replace 0 with the X, and I need to have the right moment. X, 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 Q1, Y, Y, and the 1. Q0 is replaced with Q1, 0 is replaced with X, and I have the right moment. Q1 on Y, I need to make the right moment. That is X, 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 Y, Q1, Y, and the 1. Again Q1 on Y. What to do? Have the right moment. X, 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 Y, Y, Q1, 1. Q1 on 1. What to do? Q1 on 1. What to do? Change the state to Q2, replace 1 with a Y, and I need to have the left moment. That is X, 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 Y, Q2, Y. This 1 is replaced with the Y. Now Q2 on Y. Q2 on Y. What to do? I need to have the left moment. X, 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 then Q2, Y, Y, Y. Again Q2 on Y. Have the left moment. X, X, Q2, X, Y, Y, Y. Q2 on X. Q2 on X is you have to reset to Q0. So now what is this one? X, 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 reset to Q0, Y, Y, Y. So once I get Q0 on Y, once I get Q0 on Y, that is the meaning that I have completed the zeros. That is the meaning that I have completed the zeros in the sense that we have completed ones also for the valid case. So what to do for this one? Now 1 zeros are finished. Meantime, we have to do ones are also we have to assume that finished. So that we should go to the end and check whether any ones are left out. So how to check it? We will change the state over here. We will change the state from Q0, Q1 and Q2 are used already. Now let us change the state to Q3 now. So now what to do? That is the next one. Q0 on y. Q naught on y, I will change the state to Q3, y as it is, and I need to have the right movement so that I will search any ones are left out. If any ones are left out means it's an error. If ones are left out means it's an error, that case we have to handle. That is what happens, x, y as it is, Q3 I am changing the state, then the y. Again Q3 on y. Next is Q3 on y. So don't do anything, you have to just keep on right movement. You have to keep on right movement. Q3 as it is, y as it is, you should have the right movement over there. So now what happens? Q3 on y, x, y, Q3, y. Again Q3 on y. You need to make the right movement. X, y, this is y. And it is a Q3. Next, nothing is there means these are the blank spaces. We have to assume that there is a tape is of infinite length, is of blank. Means we have ended the zeros and we have ended the ones. On Q3 on blank I should get. If I get Q3 on blank, then I will move to the final state. Q3 on blank. Either I can move left or the right. It is my wish now. So it is, I will move to the final state, QF, blank I will retain as it is, and I will have the right movement. Fine. So this is my Turing machine. This is my Turing machines. Fine. So this is how we process the Turing machine. Whether it is 0 power n, 1 power n, or a power n, b power n. So if it is a power n, b power n, use the different symbols. X and the y can be used. If it is p power p n, q power n, use the different symbols. So like that, only the notation, only the symbol names changes, the rest the concept remains the same thing. If we go for representing this one, first M is a tuple you can look. Q is the set of states. How many states we have? Q0, Q1, Q2, Q3 and the QF for your final state. What is the final state? QF. What is the sigma over there? Input symbol 0 and the 1. Tape symbols are 0, 1, X and the Y what we are replacing. And the blank will be at the end. At the left end and the right end we used to have the blank spaces over there. That is a tuple representation. If I go for writing the diagram for this one, so there are three notations we have told. This is your instantaneous description ID. There are two more notations are there. What is that one? One will be by the diagram, other will be by the table. Let us see one by one in detail. First, for the diagram, if you go with the diagram. Fine. So if you go with the diagram, so let me rub this. I hope it is clear. I will rub this one. So let me write the diagram over here. Let me write the diagram. So diagram it's already written. Fine. So now let me write it in the same page so it will be clear. So I will start from the state Q0. Q0, the first possibility is a 0. I will go to the state Q1. So how we will process Q0 on 0, I will replace with X and the movement is right. Fine. Then next Q1 on 0. Q1 on 0, Q1 on 0, 0 as it is. 0 replaced with the 0, nothing done, I will just have the right movement. The next Q1 on 1, I will change the state to Q2. So Q1 on 1, I will change the state to Q2. So 1 replaced with the Y and the movement is left. Then next Q2 on 0. Q2 on 0 will be Q2 only. Q2 on 0, 0 as it is, have the left movement. Then next Q2 on X. Q2 on X, I will go to X as it is, and I will have the right movement but change the state to Q0. Fine. Then next Q1 on Y, we have left out something. So fine. Q1 on Y, that is Y as it is Y, and I will have the right movement. Over there. Then next Q2 on Y. Q2 on Y as it is, but have the left movement. Then next Q naught on Y. Q naught on Y, I need to, this is the end case. Q naught on Y, I will change the state to Q3. Y, I will no, don't do anything. Y as it is, I will have the right moment. Then Q3 on Y. Q3 on Y. This is a Y. Y, I will return it as it is, but I will have the right movement over there. Then next at the blank space. Once I get the blank space, blank, I will return the blank and I will have the right movement, but I will change the state to the QF, so which is my final state, so the double circle will be done. So this is my start. This is how the transition diagram will be made. This is how the transition diagram for the automation is made. Right? So this is the same diagram what has been shown over here. So Q naught is your start state from where it will start, and Q4 or the QF. QF is your final state. So if we go with the transitions for the 0011 they have taken and it is a valid case, so we will reach the final state. If it is an invalid case, look over here. First 0 I will replace with the X, I will go on. First 1 I will replace the Y, I will come back. Again Q naught on Y, Q naught on Y. Q naught on Y, I will change the state to Q3. Q3 on 0 I am getting. But Q3 on 0 I have not defined. Q3 on 0 is not defined because it is an invalid case. It is an invalid case, so it won't reach to your final state, so that will be get rejected. That will be get rejected over there. So this is how we go for solving the Turing machines. So this is an example for 0 power n, 1 power n. N greater than or equal to 1. If the same question is asked for n greater than or equal to 0, again there is a question, n greater than or equal to 0. How to handle this case? So for the 0th case, so we will be there at the Q naught. So Q naught, if nothing is there, then what we should have? We should have the blank. We should have the blank. Nothing is there. Q naught on blank, we have not at all written anything over here. You can look. So in place of this one, what is this one? This case. So this case. In place of these two cases, these two won't be there. If I go for writing the cases n greater than or equal to 0. So instead of that one, what I'll have? Q naught on blank, I will go to my final state. So here Q3 on blank we are going. But here Q naught on blank only we will go to my final state, QF blank as it is and the right. So this is the alteration you need to make for n greater than or equal to 0. Means these things depending on your condition what has been given. Depending on the condition. In this case, I have used for n greater than or equal to 1. I will change the state to Q3. From there, I will go to final state. So that that condition of n greater than or equal to 1 will be maintained. But if the condition is n greater than or equal to 0, then I won't have that option. So what to do? From the beginning only, Q naught on blank. If nothing is there at the beginning, then directly I need to go to my final state. It's a valid case. That is 0 number of zeros and 0 number of ones. That is an invalid case. Fine. So now if we summarize this one, how it will happen? Fine. So what happens whenever we have the matching cases? Whenever we have the matching cases, suppose in this case for each 0 the matching is 1. So that matching we will replace the different symbols. 0 I replace with the X, 1 I replace with the Y. Again next 0 I will replace with the X, next 1 I will replace with the Y. Next 0 I will replace with the X, next 1 I will replace with the Y. Means each one, first I will match 0, I will go and search for 1. Once I get 1, I will come back and match 0. Once I get 0, go and match 1. Once I get 1, go back and match 0. Once I get match 0, match 1. So like that, the Turing machine will work. That is, it will keep on moving toward the left side and the right side. Initially, whenever we see the first symbol, move to the right and search for the symbol. If you get it, again you come back and match for the next symbol. So this will be repeated. And this is how the Turing machines are developed. This is how the Turing machines are developed for the case of 0 power n, 1 power n. Fine? And we take the next example in the next video. Fine? If you have any doubts on this one, you can clarify your doubts during your online sessions. The references for this session are taken from the textbook A.L.P. Mishra and N. Chandrasekharan, 3rd edition, Theory of Computer Science. Thank you.